my GitHub account, but I'm here at classroom.github.com for the first time. I'm going to sign into my GitHub account by clicking the Sign In button in the top right corner. Since this is my first time using GitHub Classroom, I need to authorize Classroom for my GitHub account. I can see the list of permissions that Classroom will need for my account, and I can click the Authorize GitHub button at the bottom of the page. Now that I'm in GitHub Classroom, I see the prompt to create my first classroom. When I click to create my classroom, I'm asked to choose an organization. I have the option to either create a new organization or grant access to an existing organization. Let's pause and talk more about what an organization is. Each classroom you create will be associated with an organization. An organization is an umbrella account in GitHub where you can store all of your repositories. And repositories are collections of all of the code and instructions for projects, assignments, etc. We are going to create an organization where our students' assignment repositories will live. What we will see later is that each student will have their own assignment repository where they'll do their work, and those repositories will belong to the organization that we create. Let's walk through creating and authorizing a new organization. I'll click Create an Organization, and I'll give my organization a name, Student Work Classroom Demo. I'll need to add an email address where any notifications regarding this organization will go. This might be your school email address. I'm setting this organization to belong to my personal account. You can do the same unless your school is a GitHub Campus Program Partner or a GitHub Enterprise customer, or if you have other instructions from your school that you should not own the organization that owns student code. When you choose a business account, you can enter the name of the account and you'll see at the bottom that the corporate terms of service will apply to your organization. Your institution may have agreed to the terms of service previously if they are an enterprise customer or campus program partner. Let's switch back to using my personal account. I'll click Next to create a new organization. Back in GitHub Classroom, we refresh the organization selection page where we left off, but we don't see the organization we just created. We need to grant access to that organization. I'll click Grant Access. On the Access page, we see a Grant button next to our new organization. I'll click there to allow GitHub Classroom to manage repositories in our organization. If you're prompted for a password at this step, use a password for your GitHub account. Now that I've granted access, I can close this tab and go back to GitHub Classroom. When I refresh the page, I see the organization that we've added. Remember, if you do not see your organization in GitHub Classroom, check to make sure you've granted access. I'll choose this organization to store our students' assignment repositories. Now let's name our classroom. My class is GitHub Classroom Demo. Maybe you will want to make your classroom specific to all of the students and assignments in a section, course, or semester. So consider that as you name your classroom and when you create your organizations. We have the opportunity to add TAs and admins. They will have access to our organization and can see all of the student repositories that will live there, and they'll have access to our classroom where they can manage and review assignments. In step 1, give your team access to your organization. Note that when we click here, we are taken to Organization Setup and out of Classroom, so don't forget to come back. From here, I can invite others to the organization where student repositories live. I'll enter their GitHub usernames. I'll set this user as an owner, and then I'll send them an invitation so they can help manage the organization. Now that I've invited my teaching team to my organization, I can close this tab and go back to GitHub Classroom. Here's the class we've been working on, GitHub Classroom Demo. Back on the TAs and Admins tab, I want to complete step 2. I'm going to ask my teaching assistants and administrators to join my classroom. This way, they can manage students and review assignments. I'll copy this classroom URL and share it with my teaching team. Then I'll go back to my assignments view. Now that we have chosen an organization, named our classroom, and invited our teaching assistants and administrators, we can create our student roster by clicking the Students tab. There are 3 ways to add students to our classroom. First, we can choose to import our students from our learning management system. GitHub Classroom integrates with these learning management systems and other systems on the LTA standard. Let's import students using Google Classroom. I'll choose Google Classroom and authorize it if I haven't already. Next, I can find the classroom that I want to import, and I'll import my student roster. I'll click Link to Google Classroom once I've found my class. Now I will click to import my students from Google Classroom. My student roster has been added, and I can see my students from the Students tab. On the Students tab, if I make any changes to my roster, I can sync those changes from my LMS. For our second way to add students, let's go back and add students from a CSV file. From the Learning Management System prompt, I'll skip using an LMS. At the bottom of this student view, I can choose to import students from a text or CSV file. Here I have a list of student IDs separated by commas in a .csv file. In GitHub Classroom, I'll choose to import students from this file. This gives me my student roster. For our third way to add students, we can add or edit student identifiers in the text field. Here we have our student IDs, one per line, and we don't have to use commas. We can use any identifier that makes sense to us: student IDs, first and last names, or email addresses. I'll click Create Roster. With my students imported, on the Students tab, I can see my list of students. From here, I can update students if I need to. I can sync from a learning management system, add students to the text field, or upload another CSV file. I can remove students by clicking the X next to their name. When students accept an assignment, they'll be prompted to link their GitHub accounts to our roster themselves. If a student chooses the wrong identifier, we can unlink their GitHub account from this Students tab. I'll go back to the Assignments tab, and now we're ready to create our first assignment. I'll click Create Your First Assignment. I'll give this assignment a title. We can set a deadline, which students will see when they accept the assignment. We'll make this assignment an individual assignment. We can choose to leave repository visibility set to private so that students cannot share their work with other students or developers. Or we can set repository visibility to public so that students can share their work and collaborate with other students or developers. When students accept their assignments, their assignment repository will be either public or private based on this setting. We can choose whether to grant students admin access to their repository. If students will need to add their own CI tools or add other collaborators or make settings changes in their repositories, we will want to grant them admin access to their repositories. If we don't want students making any accidental settings changes, then we will not check to grant admin access to their repository. I'll leave this box unchecked for now. Next, we can add starter code to our assignment. Let's take a look at an example starter code repository. In this repository, we have a simple Node application. In the README for the repository, we can see that the assignment is to return a string that will make the test pass. If we look at the hello.test.js file, we can see that tests will pass when the output in the hello.js file is hello world. Back on the front page of this repository, We can see that this is a template repository because there is a template label next to the name of the repository. Template repositories are GitHub's way of copying boilerplate files and directories. So this repository will copy more quickly when students accept their assignments and copy the code for their own repository. Keep in mind, a template repository will not copy the version control history of the original repository. We can set any repository we own to a template repository under that repository's settings. Back in GitHub Classroom, we'll click Select a Repository, and as we type in the name of our Education Auto Grading Example Node repository, it should show up in the list below. We'll choose Template Repository as our import method. If we're using a repository where we don't have access to change the settings, or if we want to copy over the version control history, we can use Source Importer. But keep in mind, these repositories may be slower to copy when the students accept their assignments. We can choose whether to allow students to use an online IDE to complete their work. For this example, we'll leave the default setting. Here we can add our auto grading tests. We saw our example starter code is a Node application that includes a test file. I can click Add Test and Run Node. Here we have a pre-filled test form, and we only need to give our test a name. We can set a timeout value and a points value for this simple assignment. So I'll set the points to 5 and click Save Test Case. We can add another test using Run command. So if the language we're using in our starter code is not listed here, Run command will give us a blank test form that we can complete. I can give this test a name. And if our test were a Rails test, for example, our setup command might be bundle install, and our run command might be Rails test. We can save this test case. Our third way of adding a test is an input-output test. I can give this test a name, add our setup command, and a run command. And then I can add a list of inputs and expected outputs. If I input my name, Aurelia, the expected output would be hello, Aurelia. Or if I input lowercase world, the expected output would be hello, lowercase world. We can add a corresponding list of inputs and outputs, and then we can decide how to compare them. With an included comparison, I'm looking for the output anywhere within what is returned from running the application. With an exact output, I'm looking for exactly hello Aurelia or exactly hello world to be output. Or I can use a regular expression to describe the output that I'm looking for. I can set the timeout value for this test and give it a points value. I'll save this test case. Let's revisit our first test. Here I set the timeout value to 5. That's because I know our test should take approximately 30 seconds to run, so I don't need to set the timeout for much higher than that. I also want to consider that a student might write an infinite loop that would cause a test to run forever, so I want to limit the amount of time a test will run. My auto-grading test will run against my monthly allocation of GitHub Actions minutes. Teachers who are approved for GitHub Education benefits receive extra Actions minutes on their organizations by upgrading their organizations to the GitHub Team Plan. You can automatically upgrade your organization for free from the GitHub Teacher Toolbox. Education benefits are not required to use GitHub Classroom, but it may be useful to have the extra Actions minutes. I'll save this test case and delete our extra tests. Last, we can choose whether to enable a feedback pull request. This will automatically open a pull request when the student accepts their assignment. And in that pull request, we can give direct feedback line by line on the student's changed code. I'll click Create Assignment. We see that our assignment is ready, and we have a URL that we can copy and share with our students. Let's create an assignment and allow students to complete their work in an online IDE, in this case, Microsoft MakeCode Arcade. We will quickly walk through assignment creation and focus on setting up our online IDE. If you are not yet comfortable with the general options for creating assignments, you can learn more in our video on creating assignments using GitHub repositories. Before we get into the assignment, let's make sure we have starter code. For our MakeCode assignment, I'll start at arcade.makecode.com. This way, our starter code will include all of the necessary MakeCode configuration files. Here, I'll build the files that my students will continue working on, either in block-based coding or JavaScript. When I'm ready, I can push the code into a GitHub repository. If I need to make additional changes, I can push new commits to my repository by clicking the GitHub button again. I can find my repository in GitHub. Here I can add assignment information to the README file. Turn on the template repository setting and set the organization that the repository should belong to. Now let's create our assignment. We'll give it a title, a deadline, set individual or group assignment, our repository visibility, and admin access. On the starter code step, we'll type in the location of our starter code, organization/repository name, which should show up in the list. We'll select an online IDE, Microsoft MakeCode. We can wrap up our assignment with auto-grading tests and feedback pull requests. Before I share the assignment URL with my students, I need to authorize MakeCode to interact with the repositories in my organization. I'll click Go Grant Access. I'm granting access from Microsoft MakeCode to interact with the repositories in the organization where student work is stored, in this case, GitHub Classroom student code. After granting access, I'm ready to share the assignment invitation URL with my students. Students will have a MakeCode button at the top of the README in their assignment repositories. Let's create an assignment and allow students to complete their work in an online IDE, in this case, Replit. We will quickly walk through assignment creation and focus on setting up our online IDE. If you are not yet comfortable with the general options for creating assignments, you can learn more in our video on creating assignments using GitHub repositories. Before we get into the assignment, let's make sure we have starter code. For our Replit assignment, I'll use this simple node application, Education Auto-Grading Example Node, which is a template repository that includes a built-in test file. In Classroom, I'll give my assignment a title, set a deadline, set individual or group assignment, and choose repository visibility and whether or not to grant students admin access. On the starter code step, we'll type in the location of our starter code, organization/repository name, which should show up in the list. We'll select an online IDE, Replit. We have the option of building Replit configuration files here. I can add the command that will run my application and indicate what language the application is in. Replit supports any of the languages you see listed here. We can wrap up our assignment with auto-grading tests and feedback pull requests. Before I share the assignment URL with my students, I need to authorize Replit to interact with the repositories in my organization. I'll click Go Grant Access. I am granting access for Replit to interact with repositories in the organization where student work is stored. In this case, GitHub Classroom student code. After granting access, I am directed to Replit so I can return to GitHub Classroom and indicate that I've granted access. Now I'm ready to share the assignment invitation URL with my students. Students will have a Replit button at the top of the README in their assignment repositories. Let's see how it looks when a student completes each of our assignments. I'll click into our first assignment, Lesson 1, GitHub repository. We can see here that none of our students have connected their GitHub accounts to our student roster, and none of our students have accepted our assignment. We'll copy the assignment URL that we can share with our students. When the student navigates to the assignment URL, their first step is to find their identifier in our student roster. When they accept subsequent assignments, they won't have to do the roster step again. They'll come to this page where they can accept their assignment. Because we're using a template repository, the assignment copies quickly. Once our assignment is copied, we receive a URL made up with the name of the organization where student code lives, the name of the assignment, and our GitHub username. We can also see when our assignment is due. By clicking our URL, we'll be taken to our GitHub repository where we can do our work. In this assignment, we did not add an online IDE for our students. Our students can clone the repository to work on their local machines. Or our students can edit the assignment right here in the GitHub interface. Students can edit the file by clicking the Edit button. Students can make changes to the assignment, write a commit message, and commit their changes. Let's take a look at our second assignment in Microsoft MakeCode Arcade. We can copy the invitation URL and share it with our students. Since our student has previously accepted an assignment in this class, we're brought directly to the Accept This Assignment page. Again, we have a URL that leads to the repository where we'll do our work, and we can see when our assignment is due. For this assignment, our teacher has selected Microsoft MakeCode Arcade as an online IDE. We can click the Work and Make Code button to start our assignment. In MakeCode, we can make any necessary changes and we can push our work back to GitHub by clicking the GitHub button. We can take a look at the diff of our changes and write a commit message. Then we'll push those changes back to GitHub. Back in our GitHub repo, we can see the commits that we've made. Notice that there are a couple of extra commits here for setting up the starter code and the online IDE. Now let's have our student complete the third assignment in Replit. We'll copy the invite link and share it with our students. Once we've accepted the assignment, we have a Work in Replit button at the top of our repo. We can complete our work in Replit which saves automatically. When we're finished, we can click the version control button on the left sidebar and write a commit message. And push our changes back to GitHub. Back in our GitHub repo, we can see our commits have been added. Let's take a look at how to review students' work using our Replit assignment. We'll click into the assignment view, where we can see which students have started their assignments, which students have joined the classroom but not yet accepted the assignment, and which students have not yet connected their GitHub accounts. For the first student in the list, we can see that their latest commit passed, how many points they've earned from auto-grading tests, and how many commits are on their repository. We have 4 buttons which will help us assess their work. The review button will bring us to the automatically generated feedback pull request. We enabled feedback pull request when we created this assignment. In the pull request, we can have a discussion with our students. We can leave a comment. We can take a look at the Files Changed tab and leave feedback directly on lines of code. The View Tests button will bring us to the Actions tab, where we can see the output of our auto-grading tests since the latest commit. Here in the GitHub Actions tab, we can see which commit we're looking at. If we open the auto-grading dropdown, we can see the output from the test. In this case, the test passed and the student earned 5 points. Let's take a look at the Actions tab. We can see other tests that ran on other commits, such as this added my name commit. If we click into auto-grading and open the auto-grading dropdown, we can see that here the student returned their name instead of hello world. This test failed and the student didn't earn any points. The View IDE button will open the student's work in their online IDE. For this example, we used Replit. We can take a look at our students' work in Replit, and we can run their code from here without having to pull their files down locally. This lets us use the same development environment where the student did their work, and we can quickly replicate any bugs. The fourth button is Go to Repo, which will take us to the front page of the student's repository. From here, we can take a look at files, clone the code, see the feedback pull request, the test under the Actions tab, or we can open the work in Replit. Let's create a group assignment in GitHub Classroom. Assignment setup is similar to creating an individual assignment, but when we choose group assignment, we have a few new options. We can choose an existing set of teams if we've created a group assignment before. We can name our set of teams and reuse these teams on future group work. We can set a maximum number of members per team and a maximum number of teams. We'll use our Education Auto-Grading Example node starter code, and we'll select Replit as our online IDE. We can set up tests and enable feedback pull requests. Now let's share the assignment URL with our students. The first student to accept the group assignment can create a new team. We'll call this AJ's team. The team's repository URL is made up of the name of the organization where the student's code lives, the name of the assignment, and the name of the team. Since we set up Replit as our online IDE, we have the Work in Replit button. In the meantime, let's have a second student accept our group assignment. The second student to accept an assignment has the option of joining an existing team up to the limit of team members that we set, or they can create a new team up to the limit of teams that we set. We'll have the student join the existing team. We can see student number 2 is joining the same repository with AJ's team appended to the end. If we had chosen MakeCode as our online IDE, or if we had students working without an online IDE, all of the team members could do their work in this repository, making commits, opening pull requests, and resolving merge conflicts. Since we've chosen Replit as our online IDE, we can take advantage of Replit's multiplayer functionality. Each student can see that the other student has joined the REPL with them. Student number 1 can make a change to the file and push their work to GitHub. Student number 2 can see in real time the changes that were made by student number 1. Back in GitHub Classroom, we can see that AJ's team has gotten started. We have the same buttons as on an individual assignment for assessing the student's work. In the feedback pull request, or if we were looking at the list of commits, we can see which student contributed what. Now that you've had a look at GitHub Classroom, try it for yourself. Visit blog.github.com and take a look at how to set up your digital classroom with GitHub Classroom. This post will walk you through the steps as you try them out for yourself. Speak with other teachers in the GitHub Education community at education.github.community. Take a deep dive with our GitHub Classroom help docs at classroom.github.com/help. You can also learn more about how to use an online IDE for assignments. Learn more about version control and other GitHub best practices at lab.github.com. And if you have any questions or get stuck along the way, contact the GitHub Education team at this URL. The GitHub Teacher Toolbox includes dozens of offers from GitHub partners, each providing a free and unique benefit available to all teachers and researchers who are verified for GitHub Education benefits. One benefit is the ability to upgrade any organization to the GitHub Team Plan, which grants you more GitHub Actions minutes, which you can use with GitHub Classroom's auto-grading feature. If you're not already verified for benefits, go to education.github.com/teachers and click Get Benefits for Teachers. Click through to find our discount request form. Select faculty, choose an email address, preferably your school email address. Let us know the name of your school, add dated proof of employment, and tell us how you'd like to use GitHub. If we are not yet familiar with your school, please enter the additional information when prompted. Once you are approved, return to education.github.com/benefits. Click into the GitHub Teacher Toolbox. Sort by company to list offers in alphabetical order. Find the GitHub offer for self-serve free team plans to academic organizations you own. Click the GitHub link below that offer to find the upgrade page. Click to automatically upgrade any of your organizations. Refresh the page to see the discount is applied immediately. Learn how to teach with Git and GitHub. Join a community of other teachers. Attend conferences with the GitHub Education team. As a GitHub Campus Advisor, you champion the use of real-world tools at your school. To join the program, visit education.github.com/teachers/advisors and click Begin the Training. You'll be prompted to accept a GitHub Classroom assignment. Once you have completed all of the modules, submit your application for review in the GitHub Teacher Toolbox. Have a quick chat with the Teacher Program Manager so the GitHub Education team can get to know you. Then you'll be ready to lead the way for developer best practices for your students and your colleagues.